So, a very interesting presentation, full of energy and a lot of initiative from TNPL. Thank you very much. So now we open the floor for the questions, and please raise your hand so that we can have some. Please introduce yourself.
Yeah. Good morning. I'm Paritosh Rai from Hyderabad. My question is to Mr. Madan. So, for changing the motors, old motors, they have selected IE3 and IE4 grades. Why you have not jumped to IE5? What was the cost was the reason, or availability was the reason?
Actually, availability was the reason. In India, still I5 motors are not available, and equipment which we are importing from the outside country, from the other countries or European countries, we are getting I5 motor with them. But right now, we have not availability of I5 motor in India. So now that's why we are talking about I3 and I4, and our system should be capable to cater that requirement of I5 also. So accordingly, we have to improve our system, then only we can install I5 motors.
Okay. Thank you. Thank you, Mr.
Hi, good morning. This is Shantabha Pandian, Director AI and Data from Roland Technology, UK. So my question to the transformation of Impact AI for Dr. Cloudy. See, it was interesting one. So I'm willing to motivating the team to adapting the AI across all the industries. So you mentioned that, so you are taken the charge demand, right? So for this, so what are the feature engineering aspects and hyperparameter tuning aspects so what are the action taken from your side to build this model?
Sorry, come again?
To build this model, so what are the feature engineering and hyperparameter tuning aspects, what are the actions you are taken on this specific model to build?
For the specific model, so what we did was, the initial thing was establishing the trend, right? Like establishing that there is a correlation. That was the very first thing what we did. And the model was the selection of the first model, that's an SVR model, the first one. And the second was K-means. Okay, these are very simple fundamental models. So we checked with that because this, if you look at it, it doesn't need a large fitting. You know, it's very straightforward in this particular case. That's why we wanted to show that, hey, if we take one symbol example and show that this is doable, then we can add on to it. So this one per se, the charge demand one, the model is complete. It's completely out there. It can be implemented anywhere where they have a charge analyzer. So initially there will be a training study, and then there will be implementation. Now going forward, the idea is to include more such parameters and find proxies where this is an industrial requirement. So if they come up with it, we'll definitely have solution for that.
Excellent. So do you have ML ops in the system to monitor the progress and performance?
Yes. So the AI engine, what I'd mentioned, Haber has an AI engine which comes with all of these, all of these processing, everything. So there's an edge device, there's an AI engine, and it does everything on its own. So that's already there.
So okay, the last one question is this a cloud implementation or it's
both. We have so these kinds of things you don't have to go to the cloud, but there are these real-time video analysis that we have. So that's done in the cloud, because these are very intense processes.
Okay. Yeah. Thank you.
Yeah. Good morning, everyone. My name is Tajinder B. Singh from XCAMS. My question is to Madan sir. So first of all, thank you very much for a detailed presentation. As you mentioned in the presentation that you have changed the blower in the ETP, and there is a wonderful improvement in DO. So it was just changing the blower, or need to change the injector system or anything else in the system?
No, we have not changed any ejector system in the ETP, but only the blower we have changed. We have increased the capacity. Earlier, we were running around 7,500 meter cube per hour. Now our air capacity is around 9,000 meter cube per hour. And giving more air in the aeration tank, we are maintaining the DO level. Earlier, we were not able to maintain the DO level in our aeration tank. Now with this technology, we have a VFT drive also. So we are consistently maintaining the DO level in our aeration tanks with this technology.
Okay, thank you so much, sir.
Right.
Hello. Sir, I am Kannan from Sheshai Paper Voucher Limited. Tirunelveli unit. My question is to Naresh Madan sir. Hello. Sir, actually, when we talk about the IE4 motors, energy efficiency, if the energy efficiency more means, what I observe means the speed of the motor is always higher than lower efficiency motors. For example, consider a 55 kilowatt pump we have, and that pump delivery not matching, always not matching out our process requirement. So there will be a small amount of throttling of valve, delivery valve. In such position, it is already, the valve is throttled. If you put energy efficiency motor means, the pump speed will be more and more liquid will be pumped, and again we will throttle the valve more. So here we will, again we lost the energy in the form of friction head. So in this case, shall we go for VFD or we suggest energy efficiency motors?
Yes, you are right. If you are throttling your pump valve and the delivery valve, if you are throttling, then definitely you will lose the energy even with the IE4 motor. First of all, your pump capacity should be as per the requirement of your process. And with IE4 motor, if you will go with the drive, definitely there will be a saving. But throttling should not be there.
Okay, sir.
Then only you will get the benefit. If you are doing the throttling in your pump and you are replacing high efficiency motor, there is no use.
Yes, sir. Thank you.
Okay, right.
Good morning to all. I am Govindarajan from Heber. My question is to Mr. Saravanan, TNPL. So, in your slide that you told in lime kiln, you are given a logic in such a way whenever the torque goes up, rises up, it needs to give VFD to run in the reverse direction, motor to run in the reverse direction till the torque comes down. So, my question is, even if it is not come down, even after running for a reverse direction, the torque is not coming down, what is the other logic or what? It's something else you would have incorporated there to come out the issue?
Yes, that's what I said. Actually, we have implemented a logic that it will try for 5 shots. That is, if the motor torque, normally the VFD, what will happen is, if it goes beyond 180 or 200%, it will drip on lower torque. So, we kept for up to 150%, it will try for 5 shots. So, more than that, if it goes for 6 shots, then the logic will be stopped. That's what I said.
The purpose not with the jam or not placed. So, there will be taking place for incorporated there.
No, see, if it is going to be a severe jam inside the crusher, we can't able to clear it. So it is better to trip the equipment or safeguard it. So for initial or minor jam, we can clear it.
Good morning all. This is Radhakrishnan from SPB. This is to Mr. Naresh sir. Sir, we have seen your excellent performance on the reduction of the IE motors or improvement in the IE motors. Have you done any case study, because the electrical energy is going to help in the driving the whatever the fluid we take. Have you done any study on the pumping system, because you are focusing only on the end which is going to driven the system? Have you done any case studies? Yes, as our colleague was also saying that pump efficiencies, or as engineering head, you take care of the pump efficiency. What is the minimum threshold you are maintaining? Now for the electrical motors, we have that IE 3, 4, 5. But for pump efficiencies, what you take care? Say it is maybe a liquid pump or any fluid pumps. For the MC pumps, any special care you are taking in the near futures? Can you share your way forward, sir?
Yes, definitely. We have to look into our pumping system also. When we are replacing the motor, definitely we have to audit our pumping system. If we are replacing the motor with the pump, definitely we have to do the audit of the pump also. If your pump is efficient, then you are replacing the motor with high efficiency motor, then only you will get the benefit. So parallelly we are doing the pump audit also. Recently we have completed the motor audit, and we are doing the audit of our pumping system also. Collectively, we will take the decision how much capacity we have to install. After auditing, if the motor capacity is required lesser than the existing one, definitely we will go with the less capacity motor to get the better efficiency from the system. Because that is the system integration, and we have to look into the total system, then only we will get the better energy efficiency benefit in that.
Good morning. My name is Raghavan. See, it is Mr. Costa from Heber. So we are upgrading system from computer to this one cloud and AI. There are several chances for the risk. So what are the risk expectation and risk management in these systems? Because recently the Microsoft failure last week, lot of flights, entire world is disturbed. This is a very huge, even daily around 60, 70 flights. So AI fails, what is the next alternative? It is artificial intelligence. What is our intelligence going to do?
So at Haber, we take security as a very important parameter. So what we have done is even for any of the system existing, right? So we have three different levels of security channels. So one, it's not connected over the normal internet, So if you have to get into our system, there are layers of security that you have to go in. That's on the breach kind of a side. The other side is data, right? So all the plants, they have very sensitive data being generated. So that's the storage of those data is all in encrypted format and all in multiple hard disks. So that there is always a backup. Now that's with the storage. Now coming to the next stage of when AI is doing something, right? It can definitely predict something wrong. So there are three different case scenarios, right? One is an external breach. We have measures for that. Second is the data storage and the security of that. We have measures for that. The third being whether the model prediction itself has. So with AI, the advantage is that till the time you make sure that what you're feeding in is right, the AI will always give you faithful data. But the moment you have some error input coming in, it could be a scaling error. Instead of milli, we have micro, something like that. Definitely there will be problems. But there are enough security checks that's been kept in all AI systems.
So I think we don't have any more questions. So I'd like to ask you one question, because this model you have developed, and it will depend on the anionic trash and some charge demand. So depending on the inputs like our raw material, are you planning to have different modules for different types of furnish?
Yeah, so coming to this, so depending on the furnish, so there is a entire program code to cater for that. So the thing is, it checks, so if depending on the plan we are implementing and depending on the furnish they have, there is an initial check to see what kind of furnish came in. So the idea is to have, when the furnish comes in, we check from that side. Like, when the bale is there, if it is recycled furnish, you check that, if it's virgin, then we check that. So from that, the data is fed into the AI engine. So that's the beauty of it, right? You can have very complex inputs coming in. Even if there is a change in pH because you added some coagulant at a different stage, even that comes in. And the final stage is the AI engine should be powerful so much so that even if there is a weather change, if it's a very moist day, compared to a normal dry day, the AI will be able to handle that.
We can understand how AI can address, but the issue is like you need a correlation, so database must be required. So one question more to Mr. Madan. Madan Saab, we know that the starting load current is very high for IE for 3, 4, 5 motors. So how exactly you are, have you evaluated first of all your switching system, switch gear system and protection system in your distribution, and how are you going to address the harmonic distortion if there is any?
Yes, your first question is regarding the switch gear. Yes, we have evaluated the switch gear. Accordingly, we have decided on which equipment we have to go with the IE3 and which equipment we have to go with the IE4, depending upon our switch gear condition. So accordingly, we have decided, we have studied our system, and even we have invited the technology providers to audit our system and validate our study. After validating our study, then only we will go the actual implementation of the things. And your second question is towards the harmonics. Yes, motors are not generating harmonics. Drives, in the drives, yes, when we are using the drives, harmonics are there. But now we have improved drives available in the market. So harmonics is the very less in those.